Welcome to this new series, and in this series I am going to discuss physics problems of Shift 3 paper of AAI ATC 2021, and this is the first video. 5 problems are solved in this video. Thank you. The first question says, which of the following is not correct if we have A and B as two collinear vectors? So we know the collinear vectors are the vectors that are parallel to a particular line given. So this and this can be a collinear vector, this and this can also be a collinear vector, so they have to be parallel to a particular line. So the elements of both vectors are not proportional, so this is not a correct statement, because if V is a vector, then alpha times V is parallel to V. Now alpha is any real number, so multiplying alpha by V is same as multiplying each of the components by alpha. So elements of the both vector has to be proportional. Okay, so that means if you have two vector A and B, then AX by BX should be same as AY by BY should be same as AZ by BZ for parallel vectors. So this is not a correct statement. Now look at option C, which says B is equal to A. Of course the vector is same as that vector is a collinear vector. If A is equal to B, then A and B are collinear, which is correct statement, and A is equal to plus minus B, that is also correct statement as I mentioned just. So both the vectors have different magnitudes but same direction. These are also called collinear vector. So I think this is a true statement. By the way, the official answer is given option B as answer. So I'm not sure that this is an incorrect statement. I think it's a correct statement. So let's move on. Second problem says two trains are traveling at the same direction at 80 and 44 kmph and completely pass off each other in 1 minute. So if the length of the first train is 375 meter, what is the length of the second train? So let's draw the situation first. So this is the train which is moving at 44 kmph, and this is the train that is moving in 80 kmph. So after 1 second it will move some distance, say this distance, and to completely cover, they completely pass off each other, the train which is moving in 80 kmph must be here, right? So if the length of the train is, let's say, x, that we need to find, so this length is traveled by the 80 kmph train, whereas this length is traveled by the 44 kmph train. So this length is 375 meter as given. So x plus 375 plus this distance, which is 44 into 5 by 18 to make it in meter per second, is equal to, sorry, a mistake, times 60 seconds must be equal to this distance traveled by 80 km per hour train. So that is 80 km per hour, which is 5 by 18 times 60 seconds, right? So if you solve this problem, this is a simple algebra, and do the calculation, you will get x is 225 meter. Okay, so option A is correct. Now the question says train which is moving at a rate 60 miles per hour, is brought to rest in 3 minutes with a uniform retardation. Find its retardation, also find the distance that travel before it comes to rest. So the trick here is that you need to convert this 60 miles per hour to feet per second. So 60 into 5280, which means 5280 is the number of feet that makes 1 mile divided by 3600, and that would be your initial velocity. Then we need to use the kinematic formula. So this is 60 by 22, 16 into 22 by 15. Now you have to use the kinematic formula. V square is, V is u plus at. So when it comes to rest, V becomes 0. That means A is u by t. U is 60 into 22 by 15 into 3 minutes, which is 3 into 60. So we'll have 22 by 45, and with a minus sign because it's a retardation, feet per second square, and the distance traveled can be calculated from the equation v square minus 2as, and its final velocity is 0 when it comes to rest. So s would be u square by 2a, which is 60 into 60, 22 into 22 divided by 15 into 15 divided by 2 divided by 22 into 45. So if you solve it, you are going to get option A. Okay. A stone is thrown vertically with the velocity which would just carry it to the height 100 feet. 2 seconds later, another stone is projected vertically from the same place with the same velocity. Find when and where they will meet. So the initial velocity is root over of 2gs, which is 64 into 100, which is 80 feet per second, and when they will meet, their displacement must be the same. So a later particle would have a displacement ut minus half gt square, and the particle that was thrown earlier would have a displacement of gt minus 2 square, and if you simplify this, you will get u by g plus 1, which is 80 by 32 plus 1, that will give u 3.5, and for the displacement you can use this 80 into 3.5 minus 0.5 into 32 into 3.5 square, that will give you 84 feet. Okay, option C. The minute hand of a watch is 2 centimeters long. How far does its tip move in 45 minutes? So a minute hand has a angular speed omega is 2 pi divided by 60, because it travels 2 pi angle in 60 minutes, right? So the angle traveled in 45 minutes is 2 pi by 60 into 45, that is 3 by 4, and that is the angle that it travels in 45 minutes. So okay, so this is the angle it travels in 45 minutes. So the length it travels is this distance, which is basically theta times the length of the minute hand, so theta times r, so this is 3 pi by 2 into 2, that is 9.42 centimeters. Okay, option D. So ignore this 28 for now.